So, I've always wanted to build a robot. And with robot, I don't mean this weird kind of robot with wheels, which just, is a robot per definition, but nobody would really call it a robot. I mean like a real classical term robot, like sci-fi robot. 2 legs, 2 arms, looks like a human and also looks like a machine. Well, obviously I can't build it. I mean, you have companies like Boston Dynamics who, invest millions of dollars and years of experience into a robot, and, that works. But I can't just build a robot like that. So I thought how to make it easier. And I think you can just add more legs so it's more stable and it's easier to, to make. So I thought about making like a quadruped, like a dog robot, like Boston Dynamics has a dog robot too. And I think that's a lot easier. But it's still very difficult, because if you lift 1 or 2 legs to walk, it's unstable again. So I thought, well, add 2 more legs and then you have 6 legs. And if you lift 2, you still have 4 on the ground and it's still stable. So I think that's the best way to build a robot, because if you add 2 more legs and have 8 legs, then it has the same advantages as 6. It's just more expensive and more difficult to build. So 6 legs it is. I started with modeling and 3D printing some legs, and because I was pretty confident that they would work, I printed all 6 of them. Then I started assembling 1 leg to see if it even works. Here you can see me assembling the hip joint. I could have just used the servo as a joint, but I think it would look pretty bad if you had a big blocky motor on that small leg. So I decided to control the joint with a small string which can be pulled to rise or lower the leg. Then I added the vertical hip joint, which is just a servo. And after adding a small mounting bracket, I could screw on the horizontal hip joint, which is a servo too. As you can see, every joint works as it should, with the only exception that the knee joint isn't powered yet. This part is just a mounting piece. It won't be needed later, since the servos will just be screwed onto the main body of the robot. And here I'm adding the servo which controls the knee joint. This is the string that actually attaches to the knee joint. I just used the fishing line because it's very small, but it's also very strong. And in addition to that, it has very low friction, so it glides easily through the plastic pieces. The purpose of the rubber band is to pull the lower leg up, since it can only be pulled down with the fishing line. And here I'm just attaching the line to the servo to see if everything works together nicely. I mean, it works pretty good. Now I just have to find a way to control the whole thing a bit easier than to control every single joint. I really quickly designed a main body for the robot so I can put it all together and finally start writing the program. All the legs are attached now. All of them move like they should. So now I just have to attach the Arduino on top and connect everything. I just wrote a small program to see how the legs would move, and that looks pretty good. It also has more than enough power to move on its own, just with 1 leg. So I don't see a problem why the whole thing shouldn't work. The only problem I have with building it is the Arduino doesn't have enough digital pins to actually control all the servos, because these are 18 servos and there are not 18 digital pins. So I just have to get a new Arduino Mega, and then I can assemble the whole thing. And I have to combine the receiver of the remote control with the Arduino somehow. I don't know how the receiver signals are working, but I will figure it out and then I can remote control this thing. So here you can see I finished the program and plugged it all in. I only finished it for one side since the Arduino doesn't have enough digital pins, but you can see now, here I have the remote, and the more I pull the trigger, the faster the legs move. And how we will steer the end is, the more I turn to one side, the faster the left side will go. It's like a tank. the faster one side will go. If the left side goes faster, it goes to the right, and vice versa. So that's the whole principle. It's pretty easy. And the cool thing is that I can customize everything. I can make it go higher, I can make it go lower, I can make it go faster, I can even change the angles of each joint just to look cooler or how I like it. So as you can see here, the robot works quite good. The program is done. The faster I pull this trigger, the faster it walks. But the servos aren't quite strong enough to lift up the robot. As you can see here, the back leg doesn't even lift up at all. So I made some smaller legs here, which will hopefully enable the robot to stay up on its own and, well, hopefully be able to walk then, because that's not what I wanted. So as you can see now, it stands up on its own. Well, sort of. But I think that will solve itself once I redesign all the cables a bit, so that I think there is a lot of current drop. Still doesn't have a lot of power, but it's enough. And it can walk.
Since I wanted to reduce the cable mass, I soldered a custom plug so I don't need a plus and a minus cable for each servo. I noticed that the legs were wobbling around a bit, so I looked into it and I saw that the arms from the servos were really flexible and weak, so I just glued them on with a bit of super glue. It already looked a lot better, but it's still not exactly what I wanted. It's still a bit unstable. So I looked into how insects actually walk. So I found this video which shows the movement pattern of an ant. And based on this I wrote a new program which you can see here. The first pattern is more stable since it always has 4 feet on the ground. And the second one only has 3 feet on the ground, which makes it less stable but a bit faster.
So these are the servos I used to move the legs, and I only bought them because they were the cheapest I could find on Amazon. But as you can see here in the video, a lot of the gearboxes broke, so I had to buy new servos, and this time I bought more expensive servos with metal gearboxes. So hopefully it will take out all the wobble from the system, and in addition to that, not break down after a few tries. So now I just have to remove all of those servos and replace them with the new ones.
Unfortunately, the arms from the new servos were a bit longer, so I had to reprint all of the legs. I made a new body which has a lower center of mass, which hopefully will make the robot more stable, and in addition to that it is a bit smaller and lighter. Now there is way less flex in the knee joint, so hopefully the robot will be more stable. As you can see here, it worked way better than before. To finalize the robot, I made a cover which is also 3D printed. I made a removable front panel for the cover so I can easily access the Arduino. And now that the robot is finished, I think it's time to do some tests. If you listen, you can hear a crunching sound, and that's because I didn't change all of the servos to servos with metal gearboxes, and some of the old servos had completely stripped out gearboxes, and that's why it had such big trouble walking on grass. Theoretically, this robot could do some really cool stuff like walking sideways or turning on the spot or, I don't know, moonwalking probably. But unfortunately, I can't program stuff like that. Building is one thing, but coordinating all the legs to do whatever you want is, I mean, it's okay for walking, but everything more than that is pretty difficult. And you might ask yourself, why did I build this robot? What's the reason and what's its purpose? Well, the real purpose is that